Alright, in this exercise we will do the closed loft, and first we are going to create, for this chain link, we are going to create the center path geometry. And the idea to create this center path geometry will be to make two circles, which centers will be vertically aligned. Then we will create a circle of the radius 108 plus 54 divided by 2, so the circle of that radius will be, which will be tangent to a big circle. We will pull down line which is tangential and vertical to the smaller circle down, and that line we are going to then make again tangent to this circle, and that will create us the outline. So we have 228 plus 54 for a diameter of the bottom circle, and that's where we will start our origin. And the units are all for this model in millimeters. So choose the MMGS. I'm going to start sketching this at the front plane. And I'm going to start sketch just by placing a center circle. In the center circle, we'll have a diameter of 108 plus 54. 108 millimeters plus 54. So that's my center circle. Now, I'm going to make the second circle, which will be the top circle of the diameter 54 plus 54. So diameter 2 times 54. And that circle will be at 444 millimeters vertical. So I'm going to make a circle here. And the circle will be of the diameter 2 times 54. Is that correct? Yes. Let's check once again. So if this is a 54 plus 54 half plus 54 half, so this circle will be a 2 times 54 equal 2 times 54. The center line and the origin point are going to be aligned with a vertical relationship, and we need to place the vertical distance of 444 millimeters. This is the phi 228 plus 2 times 54 at the bottom. So this is the 228 plus 228 plus 1 sine 54 plus 54. Okay, so this has created the basic geometry. Now, what I'm going to do, I'm going to make a circle somewhere here, which will be tangential to my large circle. And the diameter I'm going to specify for this circle to be a 108, radius 108 plus 54, so it will be a 108 plus, let's say 108 plus, it will be the diameter will then be 108 times 2 plus 54. Because this is a 54 by 2. And I will not use any calculator, I will place all the calculation here. So it's the 108 times 2 plus 54. And as you can see, this circle is not constrained. It will become constrained when I create a vertical line, which will be tangential to this circle and will be a vertical in length. And I'm going to end it up at the new circle, and I'm going to create that this line is vertical, and I'm going to make this circle and this line our unconstrained side circle, and the line to be a tangential also. choose the tangential relationship, which will position the circle in the right place. Let's see now again at the picture. And this will be a 54 times 2, that's correct. 108. Okay, so that will be my central outline. Now what I can do, I will make a center line and I will mirror this structure, but before I mirror I will trim the circle. I'm going now to use the mirror entities. Entities to mirror will be the vertical line and the tangential circle, and mirror about center line. And then I will need to trim the inner portions of the circles, because otherwise my command for the sweep will not be able to pick up the path. Okay, so this will be my path. This is now fully defined path that I will be using there. And now I'm going to create a sweep feature. And to create the sweep feature, I will go to a sweep boss. And I'm going to choose the circular profile, and I'm going to choose that this is a 54 millimeters. And I'm going to choose my path. And SOLIDWORKS is one of a very few CAD programs which will recognize this as a closed loft, which is very difficult to compute. And here is our closed loft. Let's see if this is the diameter. Yes, it is. So the diameter 54. And here I have created my first closed loft. And if I use the plain carbon steel, and if I go to evaluate this object, mass properties will be a 27.6 kilograms. And if I display, let's see all of the annotations. Show features dimension. We will see all of the dimensions of this loft. So fairly simple, fairly powerful command, which can help us to create objects of the very intricate complexities. Example of this object will be a very difficult, practically impossible to create in other ways, or it will create too many 3 entities. If we try, for example, to have a revolve for the certain angle, then another revolve, then extrude, then another revolve, this will become really a nightmare to design. Okay, so this concludes this demonstration of the closed loft.